and welcome to What's New with Snowflake for Data Science. I'm Sri Chantala, Product Manager here at Snowflake, working on Snowpark.
Hi everyone, I'm Maxim Lukyanov, working at Snowflake on machine learning and data science. We have an exciting topic to share with you today. In the beginning, we'll start with a brief introduction into benefits of doing data science on Snowflake. And then we'll spend the majority of our time introducing our exciting new feature, Snowpark for Python. Let's get started. In data science community, it is infrequent to hear about difficulties building the model. After all, we have so many tools and frameworks to help us with that. The discussion here usually revolves about how we can build even better models than we were able to before. But what we hear frequently is about the fact that data scientists still spend majority of their time finding and preparing the data that they need for their data science projects to succeed. Finding and getting access to this obscure database in a remote department of an organization can be incredibly frustrating. Data silos is a #1 obstacle on the path of data science team. And when the data is found and the model is built, it needs to be deployed into the same data infrastructure. These jointed data infrastructures create enormous barriers to machine learning deployment workflows, which ultimately limits ability of organization to scale their ML efforts. Snowflake offers great solution to data silos problem. Organizations which adopted Snowflake enjoy uniform and secure access to their data assets. Data scientist teams can seamlessly access data across departments in their organization using secure data shares, and can go even beyond boundaries of their organization by getting access to external data sets through Snowflake Data Marketplace. The single data platform that Snowflake offers enables collaboration between teams and simplifies machine learning deployment workflows. There are hundreds of data science teams enjoying the benefits of Snowflake Data Platform. Here's a few examples. Chipotle datasets available on Snowflake Data Marketplace to improve performance of their machine learning models. Count, an Equifax company, optimized their data preparation pipeline and sped up their machine learning workflow, which powers prevention of fraud for over 9,000 businesses worldwide. And Instacart moved their scoring architecture to Snowflake, which dramatically improved performance of their prediction pipeline, which powers more than 200 million grocery item availability predictions every hour. With all of these successes, we are especially excited to announce that now data scientists can do even more directly in Snowflake, and now with the programming language of choice of data scientists, Python. To help me introduce Snowpark for Python, let me invite Sri back to stage.
Thank you, Maxime. Before we jump into Snowpark for Python, let's do a quick recap of what Snowpark is. As Snowflake grew the data cloud, we naturally needed to expand the ways users interact with the system beyond SQL. We thought deeply about how to maintain the simplicity and power of Snowflake for data warehousing while building extensibility into Engine for broader data programmability. And we also thought about the right libraries to enable deep streamlined language integration, allowing more people to work natively with Snowflake to accomplish their tasks. With these goals in mind, last year we launched Snowpark. Snowpark is a new developer framework for Snowflake. It allows data engineers, data scientists, and data developers to code in their familiar way with their language of choice and execute data pipelines, machine learning workflows, and data apps faster and more securely in a single platform. Snowpark's client-side APIs bring deeply integrated data frame style programming to the languages developers like to use. The APIs are designed to make building complex pipelines a breeze and allow developers to interact with Snowflake directly without having to move data. And on the server side, we have support for various language runtimes that allow pushdown of custom code as functions, which run in a secure sandboxed environment hosted right inside the Snowflake engine. Snowpark currently has support for Scala API on the client side and support for Java, JavaScript, and external functions on the server side. And today, we are very excited to introduce support for Python. The addition of Python to the Snowpark family of languages comes with a wide variety of benefits. First, as a Python developer, you'll be able to work on familiar syntax and constructs with the Snowpark Data Frame API that efficiently distributes computation using Snowflake's elastic performance engine, so you're never bound to the scale of a single node. Second, one of the benefits of Python is its rich ecosystem of open source packages and libraries. To make that easily accessible in Snowflake, we pre-installed the most popular packages from the Anaconda repository, and we've also integrated the Conda package manager so that you don't have to worry about doing any manual installs or have to deal with broken Python environments because of missing dependencies. And finally, and most importantly, all of your custom Python code gets pushed down to Snowflake to run seamlessly in a highly secure sandboxed environment built right into the Snowflake processing engine. Let us show you all these benefits through the lens of a machine learning workflow. To illustrate the various concepts and benefits of Snowpark for Python, throughout the presentation, we will be showcasing a series of demos structured around building a fraud detection solution. In the demo scenarios, we have Style Me Up, a rapidly growing e-commerce channel who has been experiencing transaction fraud, and they would like to implement a fraud detection solution to reduce costs. We'll see how their data engineering and data science teams can implement the various tasks involved in a typical ML pipeline, such as doing data preparation, building and deploying the model, and automating the pipeline, all using familiar programming concepts and APIs, and a rich ecosystem of open source packages available within Snowflake. Let's start with exploring the data frame APIs.
Data frame APIs is what allows you to compose your Snowflake queries in your Python program using data frame operations. The Python program can be anything. It can be a script that you run periodically, or it can be an IDE of choice like PyCharm or Visual Studio Code. It can also be an interactive notebook environment like Jupyter. Snowpark uses familiar data frame APIs semantically compatible with PySpark. If you're familiar with it, you will feel at home with Snowpark. Snowpark Query Translator supports full pushdown of the data frame queries expressed in the data frame operations to underlying SQL Snowflake. This ensures that you always have native Snowflake performance and scale when you work with Snowpark. With Snowpark, you can easily work with terabytes of data and with billions of rows directly in your Python program. Let's take a look how data frame APIs look like. We'll use data frame APIs in the initial data engineering tasks of our end-to-end machine learning workflow demo. We'll run our demo in Jupyter Notebook. So first, let's see what data sets our online retailer Style Me Up has available to solve their fraud detection problem. In Snowpark, the first step is to connect to Snowflake by creation of the session object. Let's take a look at the orders table. Here you can see how we use a session object to create data frame that represents orders table and retrieve its first rows and display in pandas format using built-in pandas support. In the orders table, we can see a transaction ID, the IP address from which this order originated from, and the delivery address, among other details. We also have orders detail table that which is a simple table that contains details of the items that were purchased in each order. Now with these two tables, our goal for the data enrichment task is to enrich this data set with 3 additional features. Let's start with adding average price per item feature. We'll calculate this feature using order detail tables. And below this Snowpark data frame query illustrates how you can do it in Snowpark. We'll join orders and orders detail table using join operation. We'll group by transaction ID and simply calculate average of the price and save it as an average price per item column. Let's take a look under the hood how this query expressed in Python was translated and executed on the Snowflake. To do that, let's take a look at the query history. Here is our query that we just executed. In query profile, we can see that operations that we expressed in data frame operations were pushed down into Snowflake. We can see that our join operation joins orders and orders detail table, and aggregate operation performs the average that we requested. In the query view, you can also see the full SQL that was generated for our data frame query operations. While we expressed our query in data frame Python operations, we were still able to take full advantage of Snowflake Elastic Query Engine. You can see that our query processed 1 million of rows in about 4 seconds, while without any movement of the data from Snowflake. Let's move to the next stage of our demo. For the next two enrichment operations will take advantage of the external data sets available on the Snowflake data marketplace. We have acquired two data sets from IPinfo company. The first data set, IP address privacy detection, allows us to determine for each IP address whether it was mask-defined VPN, proxy, or Tor network. We have a hypothesis that adding this signal into our machine learning model will improve its prediction power. Similarly, we'll use geolocation dataset, also from IPinfo company, to map IP addresses and zip codes into their geographical coordinates. First, let's join information from our privacy dataset. This is a fairly complex join, which requires us to do join in basically two steps. The first step is a